Dear students, in this video we are going to check for the multi-level optimization. Okay, so what is meant by optimization? Already we have learned in so many algorithms, traditional or agentic algorithms, removing the complexity. It may be space complexity or time complexity. We are not bothered about the space complexity as we have reduced the cost of the storage devices. But coming to this time complexity, we are uh, more bothered about the time complexity. So in this example, this is multi-level. So you'll have different layers. So you'll have the upper level problems and lower level problems. So both the level problems have to be optimized. So this can be done only using the multi-level optimization. So each level, okay, in this multi-level optimization, it will have upper level problem and lower level. Upper level always depend on one or more lower level problems. And this will consist its own objective function, constraints, and decision variables. So remember, you'll have two types of problems, upper level and lower level. And upper level problems will be depending on solutions of the more lower level problems. And it will contain three parts, constraints, decision variables, and objective functions. Next. So the key concept, hierarchical structure. Why? Because we have upper level and lower level problems, we have to follow the hierarchical structure. Next one is leader follower dynamics, often termed as bi-level optimization, where the leader makes the decision first and the follower will make the decision in response. Third one, objective functions and what are the rules? What is the objective functions in order to optimize and what are the rules set to other levels? So four things, hierarchical structure, leader follower dynamics, objective functions and constraints. And types of multi-level optimization are bi-level optimization, tri-level and multi-level. So in the bi-level optimization, we'll have only two levels and leader will be there and a follower. Leader will decide what to do, that is what is the optimization part, and follower should follow it. Tri-level optimization, it will have three levels, even more complex than this one. Okay, and remember the output of the lower level will be considered for the higher level, that is upper level optimization. And multi-level is, it will have the hierarchical levels. So it will have more computational challenges and all the levels have to be worked according to the required decision or constraints what the final decision has been made for each level. Next, what are the applications we are going to use? So we can use supply chain management, energy system, transportation planning, economics, and game theory. So in the supply chain, so we have to optimize the production, inventory, and distribution decisions. And all these have to be optimized. And the inventory will depend on the production. Again, distribution will also depends on the inventory and the requirement. So this is supply chain. Next one is energy system, where the energy production, distribution, and consumption. So consumption will always, production will always depend on the consumption. If the consumption is high, the production will be more, and this distribution will depends upon the consumption and production. Okay, so who is required, who is requesting, and who is producing. So this have to be balanced with the distribution. Next one is transportation planning. So here you have to go for the decision making, like according to the infrastructure and traffic management. So how the infrastructure already developed or any requirements are there for that and how to manage the traffic. And next application is economics and game theory. So always in the game model, leader follower dynamics in markets are competitive environments and competitive environments will be helpful for economics and game theory. Heuristic methods, okay, for these are the solution methods. These are the application and these are solution methods. So heuristic methods like genetic algorithms, simulated yielding, particle swarm optimization will provide the approximate solution. Exact methods like branch and round, cutting planes, and dynamic programming for exact solutions. And we have the decomposition techniques like you will divide the complete problem into smaller, more manageable subproblems in order to make the complex problem into simple. And what are the challenges? So for this particular multi-level optimization, complexity, computational cost, and convergence. So as there is more interdependencies between the level, will lead to the highest complexity problems. So in order to overcome that, you have to manage and balance between all the levels with the optimization constraints. And as we are working with the significant more complex problem, all the computational resources have to be maintained. So we should not go beyond the defined computational cost and convergence. So whatever the optimization solution we are going to give, that should be compatible with all the hierarchical structure. So it should be optimal. So it will be very difficult in order to make all the levels for this. So finally, multi-level optimization is a powerful approach for tackling complex hierarchical decision-making problems. Though it is sophisticated and substantial computational efforts are available for this. Thank you.